Okay, this is section 1.4, again, functions and limits continued. This is the tangent and velocity problem. This is the well-known problem. Okay, what's the tangent problem? Actually, that's where the calculus was focusing on many years ago. Tangent to the circle is just this line. So if you have a circle, tangent to the circle is a line that intersects the circle at just single one point. Okay, that's the definition. And for this function, for example, we have this t, okay, it passes through that, okay, as well. So it's a tangent to find an equation of the tangent line to the parabola y is equal to x squared at the point P11. Actually, in the previous, maybe I should explain a little bit more here. So we define the tangent as intersecting the graph at one point, but sometimes this may not happen. Like in this case, at P, this is the tangent line. However, it crosses the function as well, the graph as well. So this may happen, okay? Don't worry about that. Okay. So this is the function at the point P we are talking about, okay? All right. This example is finding the equation of a tangent line to the parabola y is equal to x squared at the point P11. So how are we going to find it? In order to find it, first of all, tangent line is a line. So it has a slope. And we have a y-intercept. So how are we going to find the slope and the y-intercept? If we find the slope, y-intercept is easy because we have a point on the line. So let's try to find the slope. It is the main idea, main problem here. So how are we going to find it? So y is equal to x squared, as you know, this is the graph. So, and let's say we don't know anything about slopes. So we are in very old ages and we don't know how to do it. Okay, consider yourself like that. We don't have computers, we don't have anything, okay? So in old times, people were aware of finding the slope of a line, but of course they didn't have the tools. What they did is they just came up such a thinking. So what they did is, so they wanted to find the slope at the point P11, and then they started to draw another point on the curve graph, and then let's say this Q is an arbitrary point on this curve, okay, x squared, and we are interested in the slope at the point P11. So how do we come up with that? So what they did is they started, let me see the picture actually. Here's my picture. The idea was, look at this picture. So this is the P, this is the tangent line. We are interested in finding the line equation. They thought that they can only approximate the slope. And how are they going to do that? So they took this Q, arbitrary point, and they built a secant line. We call it secant line, S-E-C-A-N-T, secant line. It's a line that goes through 2 points on the curve, okay? And next step, they make it they move this Q towards P. And in the third one, they move a lot more closer to P. And in each time, they draw the secant line. This is the first secant line, this is the second secant line, this is the third secant line. And in each time, they found the slope of this line by using this P and Q, because we know of Q, okay? So each time they were able to find the slope of the secant line, and they observed that as they get close to the point P, the slope of the secant line is getting close to the real slope of the tangent line, Okay, that was the idea. So therefore, they started to calculate the slope of the secant line each time. Okay, they did that. So this is the slope of the PQ secant line. Okay. X is the x-axis for Q. Whenever x-axis x entry for Q is 2, okay, the slope is 3, which is whenever x is 1.5, the slope is 2.5. Whenever x is 1.1, the slope is 2.1, etc. So you are getting close to the point 1. Do you see that? 2, 1.5, 1.1, 1.01, 1.001. So you are getting close to the point 1. The point 1 is the P. Okay? Look at the slope. The slope is getting closer to 2. So we can do this on the left side of P as well. So let's get close to the point 1. 0, 0 0.5, 0 0.9, 0 0.99, 0 0.999. And then we calculate the slope. Okay, how would you calculate the slope? Let me show you the formula. You know that. If you know 2 points, right? If you know Q, 1.5, 2.5, and you know the P11, you can find the slope between 2 points as this minus 1 over this minus 1. You get the slope of the secant line. That's the formula we use all the time to find the slope. So they did that and they built these tables. And do you see that as x approaches to 1, the slope approaches to 2? Similarly here. So from the left and from the right, it seems the slope of the tangent line is 2. So that's what we did here. So we can find it by using the limit. So MQ is actually x squared minus 1 over x minus 1. As x approaches to 1, this is going to be 2. I'm going to tell you how to find it. And then the slope is 2. Once you know the slope is 2, you can find the tangent line equation, and then you're good to go. Y minus 1 is equal to 2 times x minus 1, or in other words, y is equal to x minus 1 is the answer. Okay, I talked about this picture. This is approaching from the left of it. Okay, your Q is on the left, right? Left of P. You are making this Q closer to P and closer to P and calculate MQ, and you get some results. And we have a corresponding velocity problem for calculus. And for this, same type of question you can consider. Let's see whether I can skip it. I think I'm going to skip this. It's the same idea. So you have the time interval. In this case, instead, the average velocity is going to be the same as slope of the secant line. It's the same idea. This is just an application. I'm going to skip that. Okay. Okay. I'm going to come back to this in easier terms. Okay. All right. So that's the end of 1.4, I believe.